I am starting the new chapter in class 12th, that is the electromagnetic induction, and this is the chapter number 9. Before going to different kinds of laws, before this one I will tell you about the magnetic flux. Magnetic flux. Magnetic flux. So this is just like the electric flux. I told you in case of electrostatics that when a number of line of electric field passes through the closed surface, then that is called the electric flux. Similarly here we have the magnetic field lines. The number of magnetic field lines passing through the closed surface is called the magnetic flux. The number of magnetic field lines passing through closed surface is called magnetic flux. Magnetic flux denoted by phi. So now we have this surface and the lines like this one that passing through this surface. This is the magnetic field B, and this surface has its own normal because the surface area is a vector quantity, so it has the surface area. This is now normal. This is now your that we can say the area A. So in this figure we are having this B and A, both are parallel. Now suppose if I rotate this surface through an angle beta, through an angle theta, and the magnetic field remains the same, then this will be like this. Suppose I take this surface and this magnetic field is as such. This is the magnetic field B, and now its normal will be in this direction. This is the direction of normal or the area A. So now this is taking an angle theta with this B. So this is like this one. This is now B, and this is now A. This is now like this A. Then the component of this B that is passing through this area, this we take theta. Then we can make two components. One is on this side. This is now your B cos theta, and second is on this side. This one. This is now your B sin theta. Then the component which is passing through this area, that is now B cos theta, and this component B sin theta is not passing through the area. So it has no contribution to the magnetic flux. Only the component B cos theta gives the magnetic flux. So now we have the product of the two. Magnetic flux equal to area of surface into the component of B along the normal of area of surface. So this phi is equal to A and this is now your B cos theta. So this is equal to A B cos theta. This is equal to phi. And this is what the scalar product or the dot product of the two vector quantities A and B. So this phi is equal to B dot A. This is now like this. And now from here you can see that the flux phi depends upon the area and this B the magnetic field and the angle between them, the theta. So the dot product of the magnetic field and the surface area is the magnetic flux. Thus dot or the scalar product of magnetic field and surface area is called magnetic flux. Magnetic flux phi. So from here you can see that if suppose B and A, if neither of them is equal to 0 but the theta varies, then this flux phi will vary. So we can have that at theta equal to 0 degree, phi is equal to BA. This is now your positive value. And theta equal to 90 degree, this phi equal to 0. So this is now 0 value and theta equal to 180 degree. Then this phi equal to minus B. So this is now negative. When we say this positive, it means that this normal and the B both are in the same direction. When we say this is now negative, it means that B and A are in the opposite direction. So we can draw a graph showing the variation of this phi with the angle theta. So now you see this, the variation of this one. This is now we take theta on this side, 0, and this we take the flux. Flux on this side, this is now positive, and on this side, this is now negative. On this side. At 0 we are having BA, that is now maximum. This is now so much. This is now suppose this 90 degree means pi by 2. Then this is now your pi. Then this is now your 3 pi by 2. And then this is now your 2 pi. And so on this goes. So now from this one, this goes to like this one, and on this side we are having this negative value. This is your BA. This is now plus BA. Now here this is now your minus BA. This so much. Then here this will be curved like this, and this pi by 2, then this now like this one. Again we are having like this at 2 pi. At 2 pi. So this value is here. This is not so much. And this is now plus BA, positive value of like this. So we say that the magnetic flux changes with the angle theta. So when the surface is rotated in the magnetic field, the flux will change. The magnetic flux changes when closed surface is rotated in magnetic field. So the value of flux may be positive, negative and 0. This is just like the work done. We can compare it with the work done. W equal to Fx cos theta. So now you can have the unit of this flux phi. Unit. So unit we have this the Weber WV. Weber. This is the unit in your M gas. In M gas. M gas system. And another unit is your Maxwell. Now this is in CDS. So we have the relation this, that 1 Maxwell equal to 10 raised to the power minus 8 Weber. This is not relation between Maxwell and Weber. Now this we have considered whole of the area. If suppose we take the element area of the closed surface, taking element area of closed surface, then this d phi is equal to b dot d. If suppose we take since the surface contains so many element area, so for the total flux we integrate it over the surface. For whole of the surface. Now this phi is equal to this area B dot D. This means the closed surface. We write down S. S means surface, and this circle means the closed. We are not taking the open surface, because in case of open surface this is not so. In case of open surface, some of the magnetic field lines leaks from the surface. So that this is not the exact magnetic flux. So we are taking the closed surface. So phi equal to B dot dA. So whenever there is a change in the magnetic field area and that of this the angle, then the magnetic flux passing through the surface will be zero. So this is about the this magnetic flux. Then so many questions will be there. You can solve them by using this formula, this B and D. This we have taken that suppose surface is not the surface having the only one area, the single one. Then when we are having to this B equal to B dot dA, and when we are taking the element area, then this is equal to B dot dA. So in this way we can find the magnetic flux. So thank you very much.